Alright, so in this video we're going to be discussing function inverses and how to find the inverses of a function. So for my first example, let's let f of x equal 3x plus 5. And I want to find the inverse of this function. So the first thing I want to do is to make f of x be y. And this is a step-by-step process. So as long as you follow the steps, it should be about the same every single time. Now we're going to swap my x and y. And now I want to solve for y. So I'm going to move the 5 over. Now divide by 3. So x minus 5 over 3 equals y. And then the last step, I want to replace my y with the symbol that you might not have seen before. But it's like f with a -1 exponent of x. This is the f inverse symbol. But this is my function inverse. Okay, so it's pretty easy. That's all you gotta do. Let's look at one that's a little more involved, though. Let me change the color. So g of x. Let's let g of x be x minus 4 over x minus 2. So this is one that you got to think about a little bit more. So the first thing we're going to do is to set it equal to y. Now the voodoo part, we're going to swap my x and y. And it may seem like, why do I do that? But the whole reason is that we're finding the inverse function, and the inverse function, it has to do with the compositions. We'll see in just a minute. Alright, so now it is kind of confusing here because it's maybe not clear what you're supposed to do. Because you have a y on top, a y on bottom, and somehow you got to solve for y, and how do you get the y's together? But what we're going to have to do is cross multiply. So you have like a proportion here, so you can cross multiply. So that's going to be x times y minus 2 equals y minus 4. Distribute your x ends, that's xy minus 2x equals y minus 4. Now we want to get my y's together and my x's together. Well, the y's are easier to get together than the x's are. So we can move this y over, and I can move that x on the other side. Okay, so I just move the x over, move the y over. Now notice that right here I have a y in common, so I can factor out a y. And now I can divide by x minus 1 on both sides to get my y by itself. And this is equal to my function inverse. Okay, so this one was a little more involved, and we had to be a little more careful and specific here about what we could do. But it's pretty much the same process. Okay. Alright, so these are two functions that we solved to get the inverses. But another type of question that you might see is how to tell if two different functions are inverses of each other. So let's look at how you could approach that situation. So let's say, for instance, I have f of x equals x squared minus 4, and g of x equals square root of x plus 4. I'm going to change colors just to keep it a little interesting. Okay, so to show that two functions are inverses of each other, we have to do two things. The first thing we have to do is to find f of g of x, so function composition. and we want to show that that is equal to x. We don't know if it's equal to x, but we want it to be equal to x because that's the identity function. But we also have to show the same thing over here. We have to show that g of f of x is also equal to x. So we have to show these two things, and if these two things are both true, then these functions are inverses of each other. If one or both of them are not true, then they're not inverses of each other. Okay, so let's see that. Let's look at the left side one. So this says that we're going to plug square root of x plus 4 into x here. So it's going to be square root of x plus 4 squared minus 4. Okay, the square and the square root will cancel each other out in this case. So that's x plus 4 minus 4. The 4's cancel, so I'm left with just x. So this one is good. Okay, let's look at this one. And you have to look at both, okay, because there's no guarantee that this one works. So let's look at that. So we plug in x squared minus 4. The 4's will cancel, so I'm left with the square root of x squared. Now, the square root of x squared is not x. As you may recall from a couple minutes ago, this is actually absolute value of x. Because x could be a negative number or it could be a positive number. We don't know. And there's no way to know. There's no way to get rid of this absolute value. So this is not x. It's absolute value of x. So this one is not true. So since this one is not true, these are not inverses of each other. Okay. So that's why it's important that you need to do both. Okay. Alright, so let's look at another example. Let's change colors. Let's do something brighter. Okay. So let's say f of x is 3x minus 4, and g of x is x plus 4 over 3. This, if you remember, this is similar to the first example we did in this video. It might be the same one. I don't even remember. It could be the same one. Anyway, and we want to show if these are inverses of each other. So we have to show that f times g of x is equal to x. We don't know, but we hope it is. And we want to show that g of f of x is equal to x. So let's start plugging in. So that's 3 times x plus 4 over 3 minus 4. That cancels. So that's x plus 4 minus 4. That cancels. So I'm just left with x. So this one is good. Now let's look at this one. So we'll plug in this function inside of x. So that's 3x minus 4 plus 4 over 3. The 4's will cancel. The 3's will cancel. So I'm just left with x. So this one's good also. So these functions are indeed inverses of each other. Okay. So that's all there is to it. You just got to be on your P's and Q's and careful whenever you're doing these. But make sure you do both ways you have to do to get your credit, because like you saw over here, it doesn't always work out that they're the same.